When getting started with GKE, it's essential to think about how you can design for security across multiple dimensions. Today, let's review the first areas you'll need to consider when securing access to your GKE cluster. It's important to start with defining what cluster access means. With GKE, there are two dimensions in which we access our cluster. The first dimension is the GKE API. This is where users can perform cluster operations. Rather than creating Kubernetes resources, we use the GKE API to create, read, update, and delete GKE clusters. The second dimension is the Kubernetes control plane. This is how we create, read, update, and delete Kubernetes resources in a GKE cluster. Across both the GKE API and the Kubernetes control plane, we want to ensure that users only have the access they need and nothing more. This is called the principle of least privilege. Let's review the various knobs we have available in GKE to develop a strategy to achieve this. Accessing a GKE cluster starts with GCP Identity and Access Management, or IAM. Like most GCP services, GKE is tightly integrated with GCP IAM. In GKE, roles and permissions can be assigned to individual users or an entire Google group. This can help greatly as the surface of your team changes over time. One of the quickest ways to get started with accessing GKE is using GCP IAM's predefined roles. In GKE, there are predefined roles such as admin, developer, viewer, all of which can be assigned to user accounts or a Google group using GCP IAM. It is important to note that the role will apply to all GKE clusters in a GCP project. Once assigned a predefined role, users will have a set of permissions that authorize them to interact with the GKE API. This means that they can perform operations that align with their role, whether it's creating a cluster, adding a node pool, or manually triggering a cluster upgrade. These predefined roles also give users authorization to perform various actions when interacting with the Kubernetes API. Again, it is important to note that not only does this apply to all clusters in a project, but all namespaces within a GKE cluster. Now, this can be really convenient, especially if you're a team doing your own development and your own operations. GKE's integration with GCP IAM can be a single method for configuring access to both the GKE API and Kubernetes resources within your GKE clusters. However, if we need more granular control to achieve the principle of least privilege, we'll have to be a bit more intentional, configuring GCP IAM and Kubernetes role-based access control, or RBAC, in concert with one another. We can start by looking at creating a custom GCP IAM role. Rather than utilizing the predefined roles that GKE provides, we can consider creating a custom GCP IAM role with lesser permissions. We can then use Kubernetes RBAC to define user access when interacting with the Kubernetes control plane in a GKE cluster. Kubernetes RBAC allows us to enable granular control over what namespaces and what Kubernetes resources that users can interact with on a per cluster basis. An example of this in action would be to define a GCP IAM custom role for users that don't need to manage the GKE cluster lifecycle, but do need to interact with the Kubernetes control plane for various clusters in their project. In this scenario, the custom role would be minimal, only allowing the user get permissions with the GKE API, which enables them to get their credentials to access the Kubernetes control plane. But by default, this would not give them permissions to actually perform any actions against the Kubernetes control plane. Instead, any permissions when interacting with the Kubernetes control plane would be defined in Kubernetes RBAC, which can give us the granularity we need to achieve the principle of least privilege. Now, once we have found the right balance of our GCP IAM roles and utilizing Kubernetes RBAC, GKE provides another layer for us to secure cluster access, this time around a user's network identity. Even if a user is already set up with GCP IAM and Kubernetes RBAC correctly, we may also want to verify the network from which they are running. In GKE, Authorized Networks is a feature that allows us to only enable communication with the Kubernetes control plane in our GKE clusters from a trusted set of IP addresses. This adds an additional layer of security to not only ensure that our user is authorized to perform a certain set of actions, but is also performing these actions from a trusted network perimeter. To recap, configuring GCP IAM, Kubernetes RBAC, and GKE Authorized Networks is a great place to start when building a GKE cluster that adheres to your organization's security best practices. Now that we've covered the essentials for securing cluster access in GKE, visit the links here to learn more. With the concepts discussed in this video, we're confident you'll be on your way to building a GKE cluster that suits your needs. Stay tuned as we expand on other GKE topics in GKE Essentials.